tonight. So just a brief introduction of the different types of compost. So when you take raw organic material, so you've got manures here, you've got straw, hay, leaves, wood chips, these sorts of things. These are raw organic materials. The idea with compost is to turn those raw organic materials excuse the washing machine is to turn those raw organic materials into soil. And compost is the intermediate step between raw organic matter and soil. So it's partially digested. Now there's the commercial compost available at the moment is mostly decomposed through a chemical composition. So for example, this is just an example, if you take sawdust and add a chemical form of urea, you will get a black looking digested, most people would say that's good compost, except that it's almost totally lifeless and it's just the elements held together through a chemical composition. Very poor quality input for your gardens, and it doesn't build soil, it's a good organic matter to add to your soils, but you don't get a compounding interest in your soils. It's just a one-off and you have to keep putting it on just like your chemical fertilizers. So really it's, from a regenerative point of view, from a, where you want to actually build life in your soil, it's a waste of time. Most of the commercial compost, and they're very expensive as well. What we want to achieve is living soils. You can get that through proper biological compost, biologically activated compost, where instead of just a pure chemical composition, you'll have chemical as well as biological activity. Biology being the beneficial bacteria, beneficial fungi, and also beneficial protozoa and nematodes, all of these very tiny microorganisms which you can only see obviously under a microscope. You want to encourage these microorganisms to grow and thrive, and then they will break down the raw organic material into living, rich, healthy soils much faster. You can take lifeless, dead soils, which we have here in the southwest, and within 3 years of applying healthy, life-rich compost and compost tea, you will take that dead, lifeless soil and turn it into very healthy, productive soils, which you can grow, of course, good, healthy plants, which don't require chemical pesticides or any of the poisons to keep pests at bay, because the plants are healthy from the living soils. If you want to have life, you've got to give life in a way. It's you can't get good healthy food from lifeless soils, no matter how much chemical fertilizer you put on. So that's your two basic different types of composts, one by chemical decomposition and one by biological activity. Now what we'll be making today is essentially what you'd call a mother culture, like making, say, your yeast for wine making or bread or something like that. You're making a very life-rich compost, which is then used as an inoculant for either bulk compost, or it can be brewed into a liquid form and sprayed on either very large broadacre farms or on your gardens, orchards, those sorts of things. And that's how you get the biological activity, the microorganisms into the soil, and then they will start breaking down the available organic material there and turning it into soil, living, rich soils which get better and better over time. So instead of the current agricultural system of chemical farming, which it really is like strip mining the soil, you're just continually taking from the soil and putting nothing back except poison, which of course has turned the southwest into desert and most agricultural soils in the world into desert. This system builds soil every single time you put a crop in, whether it's broadacre grains, whether it's vegetables, whatever you're growing. Your living plants will pair up with the microorganisms and build soil. They'll suck carbon and nitrogen from the air and pump it into the soils at a rate which is ridiculous. You've really got to see it to believe it. But you need those microorganisms. So the compost we'll be building today is BioVital Inoculum Compost. It was really developed by Dr. Elaine Ingham and the Soil Food Web, and Paul Taylor sort of took the complex science and simplified it down so that anybody with a basic understanding of life can put it into practice. Any farmer can do this. Basically, you don't need a science degree. It's with a bit of understanding. It's a science and an art form. But if you put enough effort in and you really try, virtually anybody can do this. So it takes the control out of the big companies and puts the ability into the hands of anyone who wants to give it a go. You've got to put effort in to obviously learn how to do it and why to do it, and then it takes effort, of course, to practice it until you get that art form right. But you'll get there eventually. So we'll go through the list of materials now needed to make BioVital inoculum compost. So the total size of the pile needs to be approximately 3 cubic meters. So that's a lot of organic material. It takes a total of 8 weeks from the first building of the pile until it's finished and ready for using in your garden, or to make the actively aerated compost tea, which is also called soil probiotic. Once the compost is finished and ready to use, it's available to use for brewing into compost tea or probiotic for 6 months. And then after that, the diversity of microorganisms reduces and it just turns into incredible soil for your vegetables or tree planting mix or anything like that. So the idea behind building the BioVital compost is to put as much diversity of ingredients in fairly specific ratios and quantities, but you want a huge diversity of microorganisms. What we're looking to achieve is to literally trust nature. So put as much different types of beneficial microorganisms into our soils and allow nature and natural selection to figure out which microorganisms will establish healthy populations in the soil and which will just become food. So really we're not trying to take control as the scientists try to do. We're really putting our trust in the Heavenly Father and the natural systems, how He designed things to work, and we're just using the human intelligence He gave us actually to heal the earth instead of rape it and destroy it. So anyway, let's go through the list of ingredients, and when we in the next video we'll be going into exact quantities of how much we use. So there's 3 basic types of ingredients that go in: your green material, your brown material, and then your high nitrogen. So high nitrogen being fresh manures. You want to get as much variety of fresh manure as possible. This big pile, it's some sheep manure, but it's mostly cow manure. Cow manure is particularly good. If you can ever get cow manure, it's the best type of manure to use because it has the most, because cows are ruminants, they have a lot of microorganisms in their gut, which, like horses, for example, chickens that don't have those level and the diversity in their gut. So cows, if you can get cow manure, it's the best. Sheep is good as well. So there's 2 of the manures there. There's a pile of, it's fairly dry because it's the middle of summer, but there's a pile of old horse manure. This is normally quite high in nitrogen, but it's fairly old now, it's a few months old, a lot of the nitrogen has off-gassed. You can tell fresh manure because it has that real sort of ammonia smell, and that's actually nitrogen that's just going into the air. So we want to lock that up into the compost and put it into the soil instead of just letting it go back into the air and waste. So there's some horse manure. In these bags we also have sheep manure, and I haven't piled it up just yet, but we'll be going into the compost as well. Will be a mixture of chicken manure with yard waste from the chicken tractor system, which you can sort of see in the distance there. So that's where we get our chicken manure from as well. That's an excellent additive because it's very high in nitrogen, and there is some phosphate in chicken manure if they're eating grains. Obviously the farmers are putting phosphate on their soils, it's going into the grain, chickens are eating it, pooping it out, and you can get some phosphate from that, but only if there's phosphate in the soil where the grain was grown. So anyway, so that's the manure component. So as many varieties of manure as possible. Cow is the best, sheep and horse are good, chicken is really good. I mean, if you've got it available, donkey, llama, whatever you got, rabbit. But those are the main ones that we're using today. So the second The second component, if you just, the second component is your greens. Now this doesn't look the colour green, but this is hay. This is oat hay. Okay, there's a difference between hay and straw. Okay, straw is where, say, a grain crop is being grown, and then the seed head has been harvested, and then the plant material that's left over is then harvested. Okay, most of the nutrient from that plant has gone into the seed, and then you're just left with the plant. So straw is considered a brown material because it's very high in carbon and very low in your sugars and other nutrients. Okay, whereas hay has been harvested before it's seeded. There's a little bit of seed in here, so this is kind of borderline, but hay still, the actual plant material still has all the sugars, it has all the nutrients in, so it's a very high nutrient. This is what, this is actually from a horse property, so this is what they feed their horses. They're always looking for the best quality feed for horses, of course, because they can. But anyway, that's what hay is. Hay is the grass that has all the nutrients still in it before it's gone to seed. Okay, we've got some lucerne chaff as well. I prefer to get a bale of lucerne hay because it's cheaper, but this is all that was available. This is actually a lucerne plant here, as you can see. Now lucerne is a fairly special kind of plant because there is a specific microorganism that grows particularly well on lucerne. This is called protozoa. Now I'll just get into the nitrogen cycle just briefly. The air all around us, the atmosphere, is 70% nitrogen. When you have living soils, you'll have huge amounts of beneficial bacteria. The body of a bacteria is also 70% nitrogen. Coincidence? Not. Now, when you have lots of bacteria in the soil, and then you're adding protozoa, which grows particularly well on lucerne, protozoa's favourite food is bacteria. So protozoa are a larger microorganism, and they literally eat bacteria all day long and then poop out basically protozoa poo. So they're digesting the nitrogen which is in the bacteria into their bodies. Now the favourite food of an earthworm just happens to be protozoa. So if you want earthworms in the soil, and of course the measurement of healthy soils is how many earthworms per spadeful of soil. So if you want earthworms in your soil, which of course aerate it, when they eat tons of protozoa, of course they're putting out worm castings, which is possibly the best quality soil additive you can get as far as nutrient rich. When you have adequate levels of beneficial bacteria, and you have adequate levels of protozoa, which grows particularly well in lucerne, then you're providing the food for earthworms. Earthworms will breed up to eat all that good food, and that is literally how you take nitrogen from the air and pump it into your soil. So the farmers who are putting urea and all these different chemical fertilizers to get the nitrogen into their soil are turning their soil into a desert at the fastest way possible at huge expenses to themselves, and it's just stupid because you're looking at tons and tons and tons of nitrogen per hectare just sitting on top of the soil waiting to be used. So it's incredibly stupid and wasteful, but anyway, we won't go into that. So that's why we use lucerne. Hay, the freshest stuff possible. I'm only able to get the chaff at the moment because it's what's available from horse feed, but that's the best we can do for now. So green materials, you've got your hay, you've got lucerne chaff. You've got other mixture. I know it's not green much at the moment because it's the middle of summer and this was cut a few days ago, but you've got garden prunings, you've got there's some mulberry here, you've got wattle leaves, you've got there's actually a few dead parrots in there as well. It's mostly fairly green sort of material, so prunings from your garden, so branches, leaves, from any tree species, including eucalypt. There's a lot of misinformation about eucalypt. Well, it's true if you have dead soils, eucalypt does not break down, but if you have living soils, no problems there. So lots of green materials. There's also some bougainvillea. Cut that the other day and separated it because obviously it's got thorns, so you don't want that mixed in the other stuff because you'll get cut hands. So green materials, leaves, hay, those are your greens. Then you've got your browns. So if we over here, browns are high in carbon. So carbon is basically when it's digested into soil. Carbon is the in soil. You could say it's like the workbenches. It's the microorganisms or the working crew in a workshop. Carbon provides the workbench and the tools. So when you've got lots of carbon in the soil and lots of microorganisms, you're literally building soil at the fastest rate is possible. So the carbon sources, so this is straw. We talked about the difference between hay and straw just before. This is wheat straw. There's also in the bales there, that's pea straw. So the peas have been harvested and that's the leftover plant material. Pea is probably the next best if you can't get lucerne. If you can get pea hay, it's best, but pea straw is fine as well because protozoa, that microbe I was talking about for the nitrogen cycle, also thrives on pea straw. Lucerne is the best, pea straw is the next. And of course we have wood chips as well. If you don't have a wood chipper or availability to get wood chips, just go prune some trees and chop up the branches. You want branches no thicker than the diameter of your thumb. Anything too bigger than that and it'll just take too long to digest. So branches thinner than your thumb, and just chop up all that woody material with a pair of secateurs or hack it up with a machete or whatever you've got available. Wood chips are convenient and easy, and you can get bulk amounts at the moment. That's why I've got them. But if in the future you're not able to get wood chips, just get branches and cut them up as small as possible. So that's how you get, and you'll get potassium, which is a very important nutrient, through your woody material. So that's it as far as the ingredients for the carbon, the brown, the green, which is high in nutrients and vitamins, and then your manures, which is your high in nitrogen. So then we'll just go through and we'll just come through and have a look at the other additives. Now, these are all fairly expensive, and some of them won't be available in the future when things go south. But we're adding them now because firstly they're available, and they also add a huge amount of, they really kickstart building soil life. So probably the most important one, which will probably not be available much in the future, is soft rock phosphate. This is calcium phosphate. You've got your three main nutrients that you need to grow food. It's nitrogen, potassium, and phosphorus. Nitrogen you get through the nitrogen cycle from the air if you've got living soils, okay? Potassium comes from your woody material, from branches and tree litter and things like that. But phosphorus, unfortunately, if the soil is naturally poor in phosphorus, you have to add phosphorus. If it's not there, it doesn't come in any other source. Okay, so calcium phosphate is the best. It's non-toxic. If all you've got in the future is, say, there's a big pile of superphosphate. Superphosphate is the chemical farming equivalent. It's extremely acidic and will kill all the soil life, and will basically get locked up. So don't just put superphosphate directly on the soils. Most farms have huge stores of superphosphate. If you have to, if that's all the phosphorus available, say that's all you've come across a big pile and that's all you've got available, what you want to do is you want to dissolve that superphosphate in water, and then using whatever is available, try and bring that pH up. So it's very acidic because it's phosphoric acid. You want to bring that pH up, whether that is by a long composting process, soaking it in wood chips, and then adding good healthy soil to it, and waiting till it's, things can start growing in it, and then adding it to your soils. That'll be probably a way of getting your phosphorus in the future if you can't get hold of this soft rock phosphate. Phosphorus is necessary for plants to be able to produce seed and fruits. You won't get good seed and fruits if you don't have enough phosphorus in your soils. The other one, which, and unfortunately all of our soils definitely in the southwest, are completely deficient in phosphate. We just don't have, it's just not exist. We have to truck it in, unfortunately. The other thing which our soils are totally deficient in is trace sea minerals. So these, luckily enough, you only need these amount in very small, that's why I say trace, very small amounts. We're using Acadian kelp meal. First, we have it available. Secondly, this kelp is farmed. It's from the growing tips of the kelp, which is extremely high in the growth hormones. In the future, if you can't you probably won't be able to get hold of this stuff. if you can take a trip to the beach, getting hold of any seaweed, but particularly kelp. Kelp happens to have growth hormones in it, which most other seaweed does not have. So you want to get hold of kelp. It'll never be quite the same quality as this stuff because this is the growing tips concentrated source, but you will get lots of sea minerals in your soils if that's the only way you can get hold of it. This is what it looks like at the moment. Very fine sort of meal. So that's the other big one. The other things we're using here to make our compost today, this is liquid kelp. So this is basically the kelp that's been composted into a liquid source. Once again, we're using it because it's convenient. Eventually we will have the time to be able to make our own liquid kelp by harvesting our own seaweed and then composting it down into a liquid form. It's handy in a liquid form because you can use it to make compost teas, and you can spray it on plants say you've got a severe drought stress, or you've got severe frost or something like that. If you spray seaweed solution on these plants, it gives them a really fast kick, like a real boost of health to try and help the plants to deal with that stress event. Say there's a major plague of locusts or anything of that nature, and once that problem's gone, giving it a dose of liquid seaweed is going to reduce the chances of those plants completely dying. It'll help them to bounce back. We've got liquid fish today as well. Once again, this is not an absolutely essential in the future if you can't get hold of it. It's a really good source of nitrogen. So when you combine liquid fish with wood chips and these microorganisms, you grow a beneficial fungi at the fastest rate that we know of. It's the way the nitrogen is in the fish is particularly beneficial, and it's got trace minerals as well. You can make liquid fish yourself. It takes quite some time. You need a lot of fish, but basically you take the frame. So once you've taken the flesh off to eat, you're left with the heads and the tails and the spines, the bones and that sort of thing. They get cold composted down. Essentially, you put them in a big barrel, cover it with water, and let it sit for a few weeks or a couple of months until it turns into a slush. It'll stink like nothing else, but it's an incredible fertilizer. So that's the way you can get liquid fish and also sea minerals into your soils when you can't buy this stuff in a barrel. The other thing which so this liquid fish is a booster for beneficial fungi. A real booster for beneficial bacteria is molasses, which of course is just essentially it's sugarcane juice, basically. Molasses kickstarts, when you combine molasses with straw, it boosts bacterial growth really, really a lot. If you can't get that in the future, we can grow sugarcane here at least. You can simply chop sugarcane into small pieces and add that to your compost as well. Not an absolutely essential to building good compost, but you want to get as much different types of ingredients possible because it adds that diversity. You get the diversity of the microorganisms, as many different types as you can possibly get, and then you put them out onto wherever you're growing and let nature select which ones are the best suited for that condition. Because a lot of biological agriculture at the moment, what they'll do is in laboratories they'll breed up one specific strain of bacteria for one specific plant and put it out and then wonder why it doesn't work or works very hit and miss. So it's just trying to take control of the Heavenly Father's creation, as opposed to just, I guess, obeying the rules and the laws of nature, bringing it all together and saying, okay, we'll just let you take it from here, do what you do best. So the other one we're adding, the last one which we're adding today, is soluble humate granules. This is potassium humate, and it's obviously in a soluble form. Once again, this is not an absolutely essential. Humates is what is formed when as I mentioned at the start of the video, the raw organic materials have been broken down by biology into soil. Essentially, this is a liquid soil. So the reason we're using this, and it doesn't cost a huge amount at the moment, but the reason we're using this is because in order to get our compost to the highest diversity possible, we're adding essentially workbenches for the microbes we want to breed up. So we're breeding up the microorganisms, but also giving them somewhere to work and keep converting raw organic material into soil. So in the future, if you just get a couple of buckets of really healthy soil and add that to your compost, and you'll get pretty much the same effect. I also need, there's two more things which we're adding today, which we need to talk about. We've got some old partially composted wood chips, okay, and I'll see if I can find it. We've got this stuff in particular because, right, here we go. Okay, I don't know if you can see it, maybe you need to zoom in, but if you look very closely, you've got like little white, fine threads. They're not roots, these are mycelium of beneficial fungi. Now what fungi do, they do what almost nothing else in creation can do. They eat the sugars in wood, which is in the form of lignin and cellulose. They eat those sugars, they digest it through their activity, and then will feed those sugars to your productive plants. So we're adding these wood chips to the compost to get those microorganisms, the beneficial fungi, into the compost. Any good soil is going to have this material happening. Say you have a branch that's fallen down. If it lands on where the good soil is and you've already got these in the soil, these then digest that branch into soil. I mean, at the moment, anywhere in the southwest in the forests here, you have huge amounts of woody material which falls, the branches fall off the trees, and it just sits there for years and builds up until you get a bushfire. When you've got living soils, and especially over the winter time when you've got more moisture, when you have these beneficial microbes in huge amounts in living soils, those branches will digest down much faster into soil. So of course it's a long-term solution to reduce bushfire risk, but it will do that. And of course turn those branches into soil as opposed to being a problem for bushfire risk. So this is why we're adding this to the compost, just to add more diversity to our compost, breed these little guys up, these fungi, into huge quantities. So when we spray them onto our pastures and forest areas, orchards and whatnot, these will digest any fallen branches. We can then use chop and drop mulching, so pruning the trees, and then instead of using a wood chipper, just letting the branches drop down, maybe cut them up into smaller pieces, knowing that we have these beneficial fungi in the soil, and it's going to actually digest those branches into soil. So that's an important one. Keep note of. The other thing we're using as well today, the last thing, this compost is being built to supply soil probiotic and compost tea for a property not too far away from here, which is quite literally a desert. So what we've done is I've taken some soil, some native soil. From there, this is what their soil looks like. See all that dust? It's literally a desert. It's a granite sand with a little bit of clay in it. It's lifeless, as you can see. Nowhere on Earth is ever completely lifeless, but it's no good for growing anything at the moment. But there will be some indigenous microorganisms. There will be something alive in this desert soil here. Sand, subsoil, it's not really topsoil. There will be some microorganisms that are able to survive in here. We're going to add this to our BioVital inoculum compost to breed up these microorganisms that are so tough they've been able to survive in this. Okay, so we want to breed them up into large numbers. So of course that will help to kickstart the populations of microorganisms on this person's property. So using soil from wherever you're going to be, you try and find the best stuff. I mean, this is literally the best stuff they've got, which goes to show you how devastating it is. This is a property which was once a rich, lush forest 150, 200 years ago, with springs and, supporting a good population of kangaroos and all sorts of birds and everything. And this is what happens. This is from one of the first farms in this area, which was established, I think, in the 1840s. And this is what, in the last 50 years, chemical agriculture has done to this place. To turn it from lush, living soils with good natural springs and everything. That's still in living memory. People still remember, the older people in the area still remember what that used to look like. This is what chemical agriculture has done. It's turned that beautiful, lush, rich landscape into a horribly eroded, lifeless, it's just a desert. It's devastating. But within 3 years, using the microorganisms and literally obeying the Heavenly Father's rules, we're going to turn this into living soils again by basically giving control away from from the scientific sort of approach of manipulating everything and just obeying the Heavenly Father's rules of how nature works, and just doing our bit, using our God-given intelligence to basically give it back to the Heavenly Father by bringing this soil to life again. Treating the Heavenly Father's creation with respect the way it should be, and not just keep raping the land. So that's about it for today. I'll tell you. I'll also say a couple of other alternatives which I don't have huge amounts of at the moment. I'll just show you just here. I haven't talked about accelerant. We have talked about some accelerants, the molasses and the liquid fish. Another accelerant is aloe vera. When you basically all you do is you just, thanks mate, you're taking the leaves, breaking up sort of this sort of size and adding this to the compost. This rich gelatin stuff in here, this is really excellent food to boost the populations of microorganisms. So if you can't get things like your liquid fish and things like that, I'll be using some aloe vera today as well. We just don't have many plants at the moment. Aloe vera is an excellent one. Comfrey is also an absolutely fabulous accelerant. What are some other ones? If you've got large amounts of yarrow, that's a good one. All of these things provide just as much diversity, various nutrients to the soil, but some of these, like particularly aloe vera and comfrey, they have these growth hormones in them, which of course boosts your soil life. So in a similar kind of way to the way the liquid kelp does, it's got those growth hormones in, but these are the growth hormones from a plant-based system as opposed to the sea-based growth hormones. So they're different diversity. So anyway, so aloe vera is a really good one to add as an accelerant. So is comfrey. So keep that in mind in the future, because aloe vera is really easy to grow here. Comfrey will grow if you've got good rich soil and you've got shade and you've got a bit of moisture as well. So and all of these of course got benefits for people. Other things you can add is Tagesafti. That's an excellent nitrogen fixing tree. Grows stacks of biomass. Good to harvest that, use it in compost. And yeah, any cuttings from your garden. The only other thing, of course, we haven't talked about is water, which is pretty important. The water, I'll just show you quickly. You don't want to just pour it on like that, because the water droplets are very large when you do that, and a lot of it will actually just run straight through the compost. You want to get, if we've got this particular one, there's so many nozzles out there, but with a very fine spray. So a very fine spray, because the water droplets are smaller, and they will actually, when water droplets are the smallest possible, they're more sticky. They won't just run off, whereas big droplets of water will hit the organic material in the compost, and a lot of it will just run off. So try and get, even if it's just in a watering can, is better than nothing, but the finest mist spray is the best. So you'll use quite a bit of water in building this compost, but it's definitely worth the water cost. So that's it, I think. Yeah.